Welcome to another set of notes. I'm going to start with a couple of jokes. Which vegetable was not permitted on the Mayflower? The leek. What didn't King Arthur get served at the Round Table? A square meal. And lastly, why were the Middle Ages also called the Dark Ages? Well, that's because there were so many knights. Alrighty, let's go ahead and move on to today's notes. We are talking about graphs of functions, okay? So I want to go over this intro. Functions convert inputs into outputs. Okay. Each function has two sets associated with it. Those things that serve as inputs and those things that serve as outputs. The domain of a function is the set of all outputs for which the function rule can give an output. Wait, did I say that right? Domain is all sets of inputs where you get an output. The range of a function is a set of all outputs for which there is an input that results in them. Okay, so when I say functions convert inputs into outputs, it's also saying functions are domain and range. So graphs are one of the most powerful ways of visualizing a function's rule because you can quickly read outputs given inputs. You can also easily see features such as the maximum and minimum output values. Okay, and so we have studied graphs individually. Today is our first day of working with creating a graph. And this school year, you're going to learn lots of different graphs and lots of different ways to create them. So we're going to start with this first one, which is completing a table. Okay, so when you are given a table to complete that. So this first example is a linear function. We'll talk about how we know it's a linear function at the end. But one of the things that we do need to make sure we have is with graphing, we will be using a ruler. If you don't have a ruler, I recommend check this one out. It's real short. You see how it's only 7 inches. So like a 6 or 7 inch ruler, it's real small, easily fits into your binder or pencil case. So anyway, moving on to part A, we're going to fill out the table for the given inputs. So each of these are inputs. There are x values, our domain. And we're going to substitute each x value into x and solve for our y. So that's going to look like 2 times negative 2 plus 3. So 2 times negative 2 is negative 4 plus 3 is equal to negative 1. So notice I had to write real small, so you need to make sure that you're writing small as well. And yes, you do have to show all work. So let's go ahead and keep going. So the next one, we're going to put negative 1 in for x plus 3. Then we're going to start simplifying. So now I have negative 2. There's my negative. Plus 3 is equal to positive 1, and my ordered pair is now negative 1, 1. So the negative 1 is coming from the x value, and the y is coming from what we saw for that output, okay? 2 times 0 plus 3. 2 times 0 is 0 plus 3, which is 3. Okay, so again, my x ordered pair, comma, my y ordered pair. And then we'll keep going. 2 plus 3 equals 5. Now I have the ordered pair 1, 5. And then the last one, we'll put 2 in for x. So it's 4 plus 3 is equal to 7. And my last ordered pair is 2, 7. Now part B says draw a graph of the function on the axes provided. So we're going to go ahead, plot our points, and then draw a line connecting our points. So I'm going to go ahead and start with negative 2, negative 1, then negative 1, 1, 0, 1, 2, 3, 1, 5, so that's 3, 4, 5, and then 2, 6, 7. Okay? And so this one I know is going to be a straight line. When I know it's going to be a straight line, I'm going to pull out my ruler and connect my dots. Like so. I'm going to have you guys do that again. So some sort of straight edge. Now let's go to C. C says, how do we know that this function is a linear function? Okay, there's a couple of different ways, and we'll talk more about this when we really get deeper into linear functions. But one way is the graph is a straight line. So go ahead and write that down. Another way is we have a constant rate of change. And we'll talk about rates of change here soon on our next video. We know it's constant because we have a straight line. So as x increases, y increases. As x increases, y increases. So it does the same increase on both. And then the last one is because of the equation. The equation for a linear function is derived from the parent function, which is y equals x, or you can look at it as f of x equals x. So those are the three different ways that we know that this one was a linear function. Next, we're going to move on to number 2. So number 2, given f of x equals negative 3/4 x plus 6, we're going to fill in the table and then graph it. Okay? So for number 2, same thing. I'm going to take negative 3/4. I'm going to multiply it by x, but this time my input is negative 4. And I'm going to simplify, so I get a positive 3 plus 6, which is 9, and then I get the ordered pair, so 9's my output, my ordered pair is negative 4, 9. So we're going to go ahead and keep doing this, times 0 plus 6 equals 0 plus 6 equals 6. So my ordered pair this time is 0, 6, then negative 3/4 times positive 4. Negative 3/4 times 4 is negative 3 plus 6 equals now positive 3. My ordered pair is 4, 3. And then the last one, negative 3/4 times 8 plus 6. I get negative 6 plus 6, which is 0. My ordered pair here is 8, 0. Same thing, let's plot these points and connect our dots to create our line. So negative 4, 1, 2, 3, 4, 9, 1, 2, 3, 4, 5, all the way at the top, 0, 6, 4, 3, and 8, 0. So that's 4, 5, 6, 7, 8. Yeah, right there. Okay? Some sort of straight edge. Connect those points. How do we know that this function is a linear function? We don't need to write down all three. We'll go ahead, you could either write that the graph is a straight line, you have a constant rate of change, or the equation parent function is y equals x, okay? So this time I'm going to just go with number 1, that the graph is a straight line. So again, you'll just pick one and write it down. All right, let's flip it over. So we are now on number 3. So number 3, right at the top it says consider a simple nonlinear function. This one is a quadratic function. Our quadratic function f of x equals x squared plus 1. We're going to fill out the function table below for the inputs given and graph the function on the axes provided. So again, very similar that we did on the front, except this time it is a quadratic function, not a linear function. So my input is negative 2. Input goes in for x. That's my simple substitution, and then we solve. Make sure you are using parentheses, especially when negatives are involved. So negative 2 squared, so negative times a negative is a positive. We have 4 plus 1, which is 5. And my ordered pair is negative 2, 5. Negative 1 squared, again, put that negative 1 in parentheses. So now it's 1 plus 1, which is 2. My ordered pair is negative 1, 2. 0 squared plus 1 equals 0 plus 1, which is 1. My ordered pair is 0, 1. And then we'll go ahead and keep going. So, again, you do need to be showing all work. Now let's go ahead and plot these points. So, negative 2, 5, 1, 2, 1, 2, 3, 4, 5. negative 1, 2, 0, 1, 1, 2, and 2, 5. This is not a straight line. This is something called a parabola. And so it's a U-shaped graph. And so when we connect our dots, we're going to try and put a tiny bit of a curve on it. We're not going to try and make it too straight of a line. There we go. And if you remember when we put our equations into Desmos.com, some of our graphs did have a curve to it. Desmos does a great job of creating that for us. How do we know that this is a nonlinear function? There's lots of reasons. We will go ahead and write down that we have graph is not a straight line. Not a straight line. We know that we do not have a constant rate of change. We know that it is not a constant rate of change because as we go over 1 and up 1, it doesn't do the same thing. Next time I go over 1, it goes up by 4. And actually, then it goes in the opposite direction, so a mirror image. So this is not a constant rate of change. And the last one is the equation. The parent function for this one is f of x equals x squared. So this is now an x squared quadratic function. Okay. So let's go ahead when this, before I go on, if this question pops up on homework, you'll just pick one of these three, okay? The last one is a little bit more challenging until you have really learned and studied all of your equations. We'll get there this year. So any of the three will work. Okay, and then this last part is a piecewise defined function. Take a look at what that looks like. Looks kind of funky, and so that's why we'll do this next time I see you in class. And so this is it for today's notes. Over and out.